And
Go
you're
ahead and give it a
live.
few seconds for everyone to. Yeah. All right, all right. Hello and welcome everyone to Ether Cosmology Roundtable number 88. Before we begin tonight's presentation, I have a special thanks and announcement to make regarding the merch. We just got notification that it is ready for pickup, so we're going to go get it tomorrow, and we will start working on getting it shipped out to everyone who supported us. Thank you guys very much. And to show some appreciation and what we did with the proceeds there, we went ahead and bought a C Star so we could. Oh, yeah, cool. That's going to auto black it out because it's black. 1 second. See if I can turn that off. We went ahead and bought a C Star so that we could take some celestial theodolite measurements and get in there and add to the data list. So here's the. It just got here today. Oh, it's going to blur it out too. Very nice. But very cool, everyone. Thank you. Much appreciated. And as we continue to grow, we'll be doing more stuff like that. All right. So tonight, Beast, if you want to bring up the document now, I'm going to go ahead and get off camera for a minute. So as some of you guys know, I am not at home at the moment. So my bandwidth is limited. So Beast is going to be helping us out with live streaming tonight. I'm going to be going over a proposal for a cohesive framework of interpretation regarding the ether using classical equations. You know, just adding the mechanism of the ether to explain what's going on, rather than saying, you know, space and time are changing as a function of the square of velocity or something like that. Let me check some DMs. Okay, sounds good. Okay, we're good on audio. Good on that. Okay. Okay, so here we go from the top. This is from Barlow Snelm. The Ether, Electrodynamics, a classical field-based reconstruction of electromagnetism. So this is
Alan?
a rather. Yes.
I'm sorry to inform you that there is no sound on YouTube currently.
No sound.
No sound.
All right.
I cannot hear anything.
Easton Galley said that it's good to go.
Okay. If
Is
it's
it
good, then
possibly?
I will double check if it's a me issue.
Yeah, I hear
it
sound.
too.
All right, we're good
Oh,
now?
good.
Yep.
Okay. Cool. Small miracles, lads and ladettes. Okay, so here we got a nice little table of contents to go over everything. Oops, there was actually I have the old one open. Give me 1 second. Beast, if you can scroll down to the introduction section now. Go ahead and get going. Actually, apparently there was an emergency fix version from Barlow. Second. All right, part 3. 3.2. All right, 1 second. Let me send this to you, Beast.
Roger Dodger.
This is the latest. What's your vector, Victor, or whatever?
Yeah, right there is good. Scroll down to introduction.
Yes, please.
All right, we are there.
All right, so I'm just going to read from this and then just kind of explain some stuff as I go along. So, introduction. This document presents a field theoretical model of electromagnetism based on a compressible, polarizable, and shearable medium referred to as the ether. We reinterpret the permittivity and permeability value or vacuum constants for electric and magnetic fields and zero-point energy within a classical ontology, with a mathematical formalism that mirrors yet deepens the standard field theory. The ether is not a particulate substance, but a continuous structure of a field or a fluid filling all of space. It possesses mechanical properties analogous to elasticity. It can be compressed, giving rise to electric fields, or sheared, giving rise to magnetic fields, meaning it can be twisted. So the compression and twisting of the field will give rise to the electric and magnetic fields. Vibrations that go on in the field will produce electromagnetic radiation, so radio frequencies and stuff like that. Instead of a continuous wave. Let's see. In contrast to relativity, we do not require curved spacetime. Instead, all electromagnetic and optical phenomena emerge from the ether's intrinsic field structure. Oops, hit the wrong button there. I got to scroll back down. Section 2, foundational assumptions. Space is filled with a continuous structure medium, otherwise known as the ether. Electric fields are compression or polarizations of this medium. Electric fields are perpendicular, shear, deformations, or twist. So the permeativity known as epsilon for electric, and the magnetic permeability for, permeativity for electricity, permeability for magnetic represents the mechanical properties of the ether, those being the compressibility and the shearability. So longitudinal waves will cause compression, and through that propagation, there will be the transverse wave, perpendicular to that electric field will be the magnetic field, and that's going to be caused by the twisting of that as the wave goes through that compressible medium. So electromagnetic phenomenon are wave-like vibrations of ether. So when we talk about charge and particles like the electron, they would say, or how they describe charge as like a fundamental thing. They don't really have an answer for it. We would just describe that as a form of ether density, and that density of ether is moving through the rest of the ether, and that's causing the that vibrational thing that's going on there is how we would explain the electromagnetic phenomenon in regards to radiation. All right, so time dilation and link contraction do not occur. Classical mechanics is preserved. So everything is with respect to absolute time, absolute space. Length and time don't change as a function of velocity or anything like that. Those values are with respect to absolute time. They're not all individually relative and compartmentalized. It is an acknowledgement of the the metaphysics of the mechanical properties of it. Okay, so the assumption. So rather than saying that space-time and geometry, like the way that they relate space and time as a function of geometry, is supposed to be responsible for our electromagnetic phenomenon and all of that, but that's where we're saying there's a medium here. So like at the beginning of Einstein's paper, when we get to the 1905 paper where he threw out the etheric framework as a medium and also as a mathematical reference point, or like that metaphysical interpretation where it's absolute and all that, threw all that out. So this is a completely the opposite of that. This is not like an ether theory that people in modern times will try and propose that for some reason they have this ether framework, but all motion isn't relative to it. So they all, so stuff like that. So this is answering everything in the first order and remaining and keeping all quantities invariant under transformation with respect to that absolute frame. So that's how we're maintaining our framework. All right, a little history on that. Now we'll get into the mathematical framework aspect of it. So the ether field described as a scalar or a vector field. So two quick distinctions right here. A scalar field would just be describing like a magnitude. A vector field would be describing the magnitude and directions, like the strength at a specific point, that kind of stuff. Whereas the scalar would just be a constant value at any point in it. It wouldn't tell you any sort of direction or anything like that. So we're going to start off using A here which is going to be representative of the A vector potential later on as we continue, but we'll just read here. So let A be the scalar field representing the ether displacement. Alternatively, we can define the vector field to capture both the compressive and shear behaviors. Now this is important because if we treat this as just a scalar field, we can't describe the shearing. We could just describe the compression for funsies to give like a conceptualization of what we're trying to describe. But by adding the shearing there, we can have direction and magnitude. So we can have like an actual dynamic way to describe the field there. All right, this field serves as the substrate for all electromagnetic interactions. Longitudinal compressions and rarefications of the A vector field manifest as the electric field, while transverse twists are shear deformations manifesting as magnetic fields. These two modes of deformation correspond to distinct but unified expressions of electromagnetic phenomenon.
Yeah.
So, go ahead. Okay, so
I heard something
using
too. Oh, sorry. Go ahead. I don't know who it
you-
was though.
I'm
You're good.
sorry, I
Using it-
hiccuped. I'm sorry, guys.
That's crazy, dude. All right, so Lagrangian density for the vector field. So when we're going to use the like ether density, like those magnetic and electric permittivity and permeability properties, we're going to turn those into a density, and then using the Lagrangian here, we're going to satisfy all the conservation laws within the system to make sure that we're not, violating all known and respected physics there. And then after we've got our field there, or after we've got our density and stuff, we can go on to explain how the total ether energy density includes the compressive and shear contributions, which are described up here by equation 3. And this gives rise to gravitational-like forces, optical refraction, and pressure gradients. So like when we get into things like the Kashmir effect and zero-point energy, how they would describe things in a vacuum, this is going to be a function of basically a pressure differential in ether within the vacuum to describe why these two plates move closer to one another, etc. When there's nothing in the vacuum and there's no charge or anything like that, supposedly. Okay, so derived electric magnetic fields and coupled dynamics. Okay, so this gets into the Maxwell's equations and how you can predict the change in magnetic or electric fields using the A vector potential. So the significance of that is that there's a more fundamental field that using that vector potential and a partial time derivative, you can then predict out Maxwell's 4 equations that are currently the primary ones, and like 20 if you want to use the old school ones or whatever. But the important part here is that you could reduce them all down to being derived from the A vector potential, which is extremely important in showing that it supersedes them in like a hierarchy, right? All right, so we'll scroll down here. So the perpendicular relationship between the E field and the B field in wave propagation arises naturally here. The longitudinal compression or rarefaction in one direction induces the transverse twist perpendicular to it, a common mechanical behavior in elastic medium. So as the ether is being compressed, it's also twisting, and that's what's creating the two components of electromagnetic propagation. So compression and rarefaction corresponds to the oscillations in ether density along the propagation axis and manifests as an electric field. In contrast, the magnetic field is sourced exclusively from twisting and shearing motion of the ether with no change in volume, only directional flow. The self-sustaining nature of the electric field of the electromagnetic waves arises from the dynamic coupling of these two deformations. The time-varying compression or rarefaction, which is noted by the time derivative and the curl of the A vector potential, which induces a transverse twisting motion to generate the magnetic field. And then you can do the time-varying twist version for the longitudinal electric field. I'm sorry, for the, not twisting, but compression or rarefaction. All right, so the static twist in compression does not produce, static twist and compression does not produce the other field, only a changing shear or density gradient as it propagates. All right, this feedback loop is the ether mechanical analog to Maxwell's curl equations. Electromagnetic waves are thus alternating patterns of compressive and twisting deformations of ether, sustaining one another as they propagate through space. To clarify the meaning of these potentials, the scalar potential, noted by phi equal to the curl of the A vector potential, represents the local compressive or rarefied state of ether relative to its natural uncompressed equilibrium. It describes how densely or how loosely packed the ether is in a given region, and thus resulting in force arising from the spatial pressure gradients in this compressive state. The term minus or the negative time derivative times the A vector potential in the electric current or in the electric field equation represents the local flow velocity of the ether field, a dynamic inertial effect. The deformation of the ether evolves over time and induces additional electric fields via this velocity contribution. So similarly to how Maxwell conceptualized the velocity of light being due to a sea of etheric vortices, and the light, the electromagnetic propagation is going through that and it's catching that velocity boost. Same kind of mechanism being described there. Together, the electric field expression, the E field, is given by minus the curl of phi minus the time derivative of the A vector potential. Reflects two complementary mechanisms from static compression to pressure gradient forces. The other from a dynamic ether motion, an inertial velocity response. This restores the physical intuition of the otherwise abstract scalar and vector potentials of a classical electrical magnetism. Now, this is really important because in modern times, right, in QED and what's the other one? Modern quantum field theory, the fields are just abstract mathematics. They have no physical meaning. They don't care so long as they can make a calculation and make a prediction. They don't care what coefficients they introduce to make things work. They don't care what rounding mechanisms they use to get rid of mathematical equations that diverge to infinity and leave no physical meaning. They don't care so long as they can make the calculation. And the sacrifice of that is that you don't have a cohesive way to explain electromagnetic propagation as like a wave through a medium that's being compressed and it's causing shearing, which is and those two changes in the ether are what are producing the electric and magnetic fields, right? They just have to say it's just like spontaneously happening out of a field of math. Like we've heard it being discussed at the highest levels of academia, and it's completely abstracted without any sort of physical meaning or interpretation. So this is trying to reestablish, that mechanism, that primary substrate, right? That more fundamental field. This is trying to give acknowledgement to it and using the vacuum constants for the physical properties, and then deriving everything based off of those properties to get density and whatnot for the vacuum to start explaining things like the Casimir effect and 0-point energy, which is basically just energy fluctuations in a vacuum that shouldn't be there. It's, well, how is random how is abstract mathematics that describe a vacuum, a field in a vacuum, giving rise to real measurements that are fluctuating, right? Like that doesn't make any sense unless you ignore the fact that electric permeativity and magnetic permeability have physical properties, right? Those are impedance values. Those dictate how fast an electric field can flow through something and how fast a magnetic field can move through something, right? So in classical, so we'll go ahead and continue to read here. So permeativity and permeability, velocity and impedance. So in classical electromagnetism, epsilon and mu are abstract constants. So remember, they can't acknowledge anything physical in the vacuum. So these vacuum constants are just, they're just what's necessary to make the other stuff work, with no physical interpretation there. So following from what Maxwell did with the permeativity values, you can derive or you can do C equals 1 over the square of epsilon and mu, which gives them was like 300 million meters per second. And then you can also do the same with classical principles in the same way that Fresnel derived Fresnel drag by assuming that the light is going through an elastic medium, and then by using those two values, the same way that they would do sound through the speed of sound through a medium using the same ratio. They came up with the speed of light on that, so we can show the same relationship there. Now, keep in mind, these might not have any physical meaning, right? Like if one of the biggest things I learned in physics is that these constants, these variables, these ratios, some of them may not have any physical meaning at all, although the ratio works out. It could, so like just kind of keep that in mind when we're proposing all this. Like it calculates out, but is it physically real? Time will tell. We can never really know for sure, but we can draw some logical conclusions and build from there. It turns out we have to have a starting unproven axiom, to start with, and then build upon that, and then use the completed form to kind of verify whether or not our axiom was true. So with that in mind, just keep that in mind. This could all just be nonsense. All right. So here, when you ratio out the same thing, so instead of using the vacuum constants, you ratio the wave speed over the density of the elastic medium, and then when that comes out, when you use the vacuum constants, you get the speed of light. So same. So right here, given by equation 13, these two are proportional using the same thing. So makes me feel like it's in good agreement with, like it's not too much of a logical leap, but again, it's just a ratio. Who knows? So this derivation shows how the familiar speed of light formula has its roots in classical wave propagation using epsilon and mu expressing the medium's capacity to resistance of electric and magnetic deformation respectively, just as K and P describe the mechanical resistance to compression and inertia. And so, like I said, same thing, same ratios to predict the speed of sound in different gases, different mediums. Same thing that predicts that comes out with the speed of light when using the vacuum constants. So additionally, the intrinsic impedance of the medium is given by Z equals to the square of mu over epsilon. This reflects the ratio of the medium's resistance to the transverse shear versus its capacity to be compressed. In vacuum electrodynamics, this is taken as the impedance of free space. So Z naught is approximately equal to 377 ohms. In this model, the constant arises naturally from the consistent mechanical properties of the ether rather than being imposed as an abstraction in an otherwise empty void. So here's the thing, lads and ladettes. If vacuum energy, right, on just vacuum energy on its own, the little particle fluctuations that pop in and out of existence, as they like to tell us, right? If that's true and that exists as a physical thing, then all motion is also relative to that, and they would have to start explaining Michelson-Morley. So that's why these fields and the concept of an ether extends beyond just like, well, maybe can we introduce it again? Well, no, because it all goes back to the implication of velocity. And the whole thing, relative to what? Well, relative to my vacuum fluctuation. Well, so that's why these things can never be addressed or brought up in modern times, because it all leads back to the big cover-up that I like to call it.
I think that, Alan, if I may, so far in this paper, there have been 3 moments where my eyebrow just kind of caught a little bit of a slant.
No
and
worries.
The third one is right here in front of us, where he talks about how impedance is 377 ohms in free space.
Is that the wrong value?
Well, I take objection more to the inadequacy of the unit of measurement. When we just look at ohms, in the classical sense, the where it is typically referred to is in electrical conduit with electric force going through the conduit, like a copper wire.
Right.
And there's a resistance to a given voltage, for example, of 377 ohms. And in that operation of measurement, you could then calculate the amount of current to it that would be going through the particular wire and per second, and then you can equate that to joules or whatever you want to do with it. But in this case, we're looking at the quote impedance of free space, which is essentially a three-dimensional concept, where a unidimensional, excuse my rather grumpy kitty on my lap, a unidimensional unit of measurement is being used, being ohms. That strikes me as really incongruent and inappropriate. I don't know about you guys. The first one was right back on. Pardon?
No, I said that's fair. Can I finish through though, and we can go through all of them because your contentions are super valid. I would just like to get through.
I just wanted to set the tone for the rest of the paper. Even that would be the way, so that we can examine his language. And this is really what my focus is on here. Back in page 1, the phrase that he used was observed relativistic effects, although he doesn't specify any.
Yeah, well, this is a super rough draft,
right?
Keep in mind.
Okay, there it is, right in the middle of the page. We just had it there.
Thank you.
That's it, right there. You got it. See it? Observed relativistic effects, but we don't know what they are. And again, he does that down on page 4 when he talks about extra electrical effects taking place at the bottom of page 4, and he doesn't specify what they are. And each time this happens, bottom of the next page, you're just getting there. There you go. Yeah, you got it. It strikes me as, well, okay, he's telling us, and it's in the middle of the second last paragraph before section 4 there. Its motion induces additional electrical field effects. No, upper paragraph, last line. That's it. He puts his finger right on it, but he doesn't go into it. So that's what I'm hoping to see more of in the latter half of the paper. Let's go for it.
Yeah.
Duly noted. We're back at 0 point energy.
Cool. All right,
and
so
377 ohms. Yep. You got it.
Oh yeah. Yep. All right, so 0 point energy. Even in absence of charge and current, the ether vibrates with a non-zero amplitude, creating a measurable energy baseline, given by equation 15. ZPE is thus the residential vibration of the structured medium, not particle fluctuations, and it varies by spatial boundary conditions. So as we go down to talk about like the Casimir effect, for example, that's going to relate to that density differential that we were talking about, created by the vacuum constants, which leads to the description of why the plates attract to each other when there's supposed to be no charge in the vacuum. And then in relation to the 0 point energy, which we were discussing earlier, is giving physical properties to, like, an abstract field of math can't produce a physical measurement. That doesn't make any sense. It's an abstract field. How is a device getting readings from that? It doesn't make any sense. So obviously there has to be something there. So this is an attempt to add to a description, or an acknowledgement rather, of what is there. And as Stone was pointing out, there's definitely more work to be done in the description, and always use caution when using constants and ratios and making assumptions and whatnot. That's like I said, that's a big thing that I've learned. Stone, was there anything else that you wanted to add, sir? Because that's basically
no. I'm good for now, thanks. Yeah, let's see how this turns out.
Let's see. So we have we do have there was something that was stuff added after the Casimir thing. So if you can scroll down to the dissectable capacitor and vacuum charge storage, and then tell me when you're ready.
Ready?
All right. The dissectable capacitor experiment wherein a dielectric is charged between metal plates and then removed while retaining the stored energy finds a natural explanation in the etheric framework. In this view, charge is not stored as a free electron on the plates, but as a polarized or compression or rarefaction of the ether within or around the dielectric medium. When a dielectric such as mylar is inserted between plates and the capacitor is charged, it polarizes the ether within or around the dielectric. Removing the dielectric will preserve its alignment and it preserves the etheric deformation within it, thus its polarization. If placed between new neutral plates, the stored etheric polarization is sufficient to induce a discharge. This directly supports the notion that the energy is embedded within the dielectric ether system and not the metallic plates themselves. So for anyone not familiar, real quick, that's in reference to
That video. Yeah.
how they explain capacitor plates and specifically dissectable capacitors, which are awesome. So as he was saying there, you could take the plates out, change them, discharge them elsewhere.
Should we play that video?
Trying to discharge. At the end, yeah, absolutely. Actually, that's a good one to end on.
We'll come back to this.
Okay.
For sure.
Yeah, because this is really significant here, because the way that the mainstream describes it is they're like, well, there's an overflow of electrons on these plates and they're just kind of hanging out there, and that's what's causing the charge. And if that were true, then the plates would you would be able to electrocute yourself when you touch them when they're not attached to the rest of the capacitor.
I'd like
But
to
you could-
add to this a little bit.
Please.
There's a YouTuber, some plasma in his channel name. You know the guy. He's about almost 30. Looks like he works out about 5 times as much as he does spend time thinking. But he does a lot of science, so he's got a good YouTube, right? But one video that he recently did was about fabricating his own electret. And it has everything to do with what we just covered here, by storing the dielectric potential or the electrostatic potential in the dielectric, in the medium, in between the plates. That we're taking that potential, and in his video, when he's making an electric to it, it's that process right there, done in the same way you would think about producing a magnet artificially. That you would raise the material above the Curie point, or in the case of the electret, you would raise the temperature of the mylar above melting point and physically conduct through it the act of capacitance charging while it is cooling, so to speak, drying, unmelting, however you want to think of what's happening with the mylar as the heat leaves, that it is happening in the presence of this electrostatic field, that it is physically conducting through it almost, but it can't really because it's an insulator. That's why it's chosen. Mylar is what it is. That as it becomes hard, as that happens, the capacitance is being held across it side to side. You are literally polarizing that stuff as you would in the case of this dissectable capacitor. Only it is forever keeping it in the material, so that you can, it is forever statically charged, if you will. Like it is always, you can think of it as always connected to the Van de Graaff generator turned on, and you can pick up stuff with it electrostatically.
Yeah, you can basically take the
remarkable.
mylar, send it to someone across the country, and it'll still have its charge.
Oh, a century from now. Yeah,
That's
absolutely
so cool.
outstanding video. I recommend
Yeah.
that. Watch that, guys.
Yeah, we're definitely gonna watch that on the way out.
Yep, good idea.
That sounds awesome.
All right, I am currently on this framework also elegantly.
This framework also elegantly accounts for the behavior of vacuum capacitor. Classical models struggle with the notion that a vacuum can store energy as it lacks polarizable particles. But under the ether theory, the vacuum is not empty, it is a structured ether medium. Applying a potential between the plates compresses or rarefies the ether between them, storing energy through the deformation of the medium itself. Thus, even the vacuum becomes a genuine dielectric under this model, within or with its permittivity emerging from the ether's intrinsic compressibility. This mechanical view resolves the long-standing conceptual ambiguities and recenters field energy as a real material effect sustained in the structure and motion of ether.
I think
So
you
here we
kind
have,
of missed the bus on that, on those two
yeah,
paragraphs. Just go back just a bit, Beast. 4 lines
mhm.
back. There you go. Great. When he says that applying the potential between the plates compresses or rarefies the ether between them, that's where I think he's not quite catching the boat. You see, the same thing is happening on Earth right here. This is everything that has to do with what we talk about with respect to electrostatics causing a gravitational effect here for us on Earth, on the ground. Closer to the ground side or the ground plate of the two plates involved in producing capacitance, or an electrostatic gradient like the one inside we live. And this is where I think he's missing the boat, that he's saying that it's compressing or rarefying it, but I don't think it is. I think it's creating a gradient of energy state between 0, the ground, and fully charged, whatever the voltage is applied at the top.
Hmm.
If you can picture that. That's the way that occurs
I
to me
can kind of.
mechanically.
So,
Good.
okay. So yeah, well, so you're more of like a static charge density gradient, and then like, so what happens mechanically in that gradient then?
Well, that's where he sees compression, because the gradient, I think, is linear, exactly like the way we experience it here.
Hmm.
So it's really a question of proportionality and ratio in your physical distance between the two plates, one to the other. What kind
Yeah, I
of
feel like it's two sides of the same
experience that's going to be
gradient.
for you?
Yeah,
Yeah,
because like,
yeah, I
because
think
we,
it is.
yeah, yeah,
So that's where this guy's kind of missing the boat.
yeah. The cross product of, or I'm sorry, the nabla vector, the nabla A vector is the density gradient, or
It's the influencer, isn't it?
it is a gradient in the scalar potential equation, the E field one. I think
Should I go back?
does it say that?
Oh, we're good right here. Glad we're clear.
Okay.
Yep. All right. So the equivalence to classical electromagnetism. So the A vector field potential is the fundamental deformation field of the ether. The phi equals minus c squared integral of the change in the vector is the scalar potential representing the ether field divergence, integrated volumetric strain compared to the equilibrium state, analogous to compression or rarefaction of a fluid. Very cool. And then we have the minus the time derivative of the vector potential. A vector potential represents the inertial effect or the local ether flow velocity, a dynamic contribution to the ether field. And then we have the
Electric
E
field.
field there, yeah, given by minus the curl of the phi, which is the A vector potential, minus the time derivative of the A vector potential, is a recast of a longitudinal ether compression and dynamic flow response. The B field given by the curl of the A field is the transverse shearing of the ether. So Maxwell's equations just become a manifestation of the ether in dynamic strain and displacement. So that shearing and compression effect that we were talking about, leading to the electric and magnetic fields. So no special relativity needed here, as the speed of light is dictated by the medium, and all motion is relative to the medium. And since we're acknowledging a medium, all motion is relative to it. So there's definitely no room for special relativity, as we acknowledge first order effects, and we have no problem describing any of the reciprocal electromagnetic phenomenon that occurs without
Speaking
using
of phenomena, I wish he had mentioned some.
phenomena.
You know what I mean? I wish that he had brought some kind of mechanical example to the table here so that he can demonstrate the variables in play. over time.
Dude, I wish I had
Wouldn't that just be
sent
awesome?
you. I wish I had sent you a preview of this so you could have given like notes or whatever, so we could do a follow up on this because this is just kind of a rough draft that's put together. But you're
Oh,
crushing it in the
excellent.
critiques department, and
Okay.
that's
I'd
what we
also like
need
to
to
see
make.
how he relates this to resonance,
That's what we
as,
need
as that
to.
would go.
Well, I think the
Get some
resonance
PC
is
on
just an
there.
acknowledgement of the impedance value, right? Like being a physical thing, because like at the end of the day,
Hmm.
if there
Hmm.
wasn't a physical thing there to cause the impedance, like then it's hard for me not to conceptualize it like that because of that. So I don't. Maybe that's
Indeed. Alrighty,
maybe that's
let's
my
rip.
bias of it, but yeah. So in this framework, the scalar potential given by phi in the integral of the change in the A field with respect to time reflects the ether's compressive state to its relative to its natural equilibrium. This generates the forces and the pressure gradient in the ether to give rise to all the phenomenon that we were discussing earlier. So the Casimir effect, stuff like that. The term minus the time derivative of the A vector potential accounts for the contribution of the local velocity. Didn't we already read this part? I think we're just
Nope.
kind of
Nope.
Oh, okay.
Nope, it's new,
Well,
but I think he might be going somewhere with that.
yeah, okay. So let's see the rate at which the deformation propagates through the medium. So again, describing that propagation rate due to those impedance values. So this dynamic term represents how moving through the structure of the ether contributes to the electric field through inertia-like force or effects. Thus, both components of the electric field arise from real mechanical effects, one from a static pressure-induced gradients and one from the velocity of the structural flow. The potentials are not abstract mathematical constructs, but measurable expressions of the ether's physical state. Standard electromagnetic phenomenon emerge as a special case from a more general field mechanics of the ether. Conclusion. The ether field theory reinterprets classical electromagnetism, quantum vacuum energy, and light propagation as an emergent phenomenon of a structured elastic medium. Permeativity and permeability are no longer abstract constants, but mechanical properties of a real measurable substrate. Time and space are absolute. Observed relativistic phenomenon are replaced by material strain effects in the ether or classical velocity composition. So for those who aren't familiar, a lot of relativistic effects that are claimed to be occurred and measured, none of them are link contraction, but they are time dilation related, but they're always they only measured the quote unquote time dilation in one frame, and then there's never any reciprocity with respect to the lab frame or the thing making the measurement or anything like that. So they kind of have this like half confirmation of what they would need to verify time dilation as defined by how it should work in relativity as the actual mechanism. So this would just be a retardation in the speed of light, because that's all it is essentially, right? When they talk about an atomic clock running slow or fast, all they're talking about is that its tick rate is going faster or slower, and its tick rate is based off of electric and magnetic permeability. So, all right. So the current models abstract away the physical substrate of the field, creating interpretational confusion around phenomenon like vacuum energy, electromagnetic wave propagation, and the nature of charge. The ether theory restores the physical meaning by treating the field as a real medium with structure, memory, and elasticity. This approach opens the path to unify electromagnetic, optical, gravitational, and quantum effects under a single mechanically grounded ontology. And that concludes our paper from Barlow Snell. Stone, did you have anything else you wanted to touch on?
I thought it was a great effort. I don't think I would get too specific after what I've already said. I think I pretty much covered what else I was looking for in the substance of the paper. Again, things get a little hairy and into the weeds when we start forking over so many formulae in a single paper like this one does. That he deals with so many abstracts at one time. It's just a massive, juggling of intangibles that I think it's really hard to convey to the reader doing it that way.
Yeah, No worries. All right, let me Stone, do you have a link to that video?
Oh, no, I don't, but I will look it up. Give me a second.
Yeah, look it up real quick, and then I'm gonna look for the It's BS video where he does a quick rendition of it. Actually, I think he let me put it on my YouTube because he made like a shorter version. Give me 1 second.
Okay, I got the tags going in the main chat.
Oh, it's double slit. Okay. And how long is that video?
That video is 16 and a half minutes.
16 and a half. Okay. All right, we'll just play yours out. But real quick, let me link It's BS in the YouTube chat because he is a great resource on that.
Should we play the whole video? Sorry, I was muted.
Play out the video that's Stone.
The plasma one. I think it's worth it. He goes through his work process and his stages of success, which I think are relevant because partial success definitely had an effect on subsequent design, and I think that's relevant.
Okay. 1.5 speed it is.
Yo, let's see. Can you send that to?
Go for 1 1/4.
There's this one.
You sending me some?
Yeah.
Okay.
All right, go ahead and play those out.
Both of them?
Or play Stones. No, just play Stones first. Can you link the other two in YouTube chat when you get a chance for me? I don't have it open. But play Stones.
I don't
Stones
wanna.
video.
It's
I'll
in the
play it
main.
later. Yeah, I'll. If someone else wants to grab the links because I'm streaming. I don't want to open the chat and like cause like a.
Oh, I got you. I'll send them to Galley.
For sure. All right, let's do it.
Despite what it looks like, this is not a magnet. Actually, it's something much more exotic, and the invisible field it emits is easily seen using this 5x5 detector array. But what exactly is the grid detecting? This video is sponsored by Factor Meals, thank God, because I can't cook. Magnets are underrated. Using an invisible Jedi magnetic force, these little objects attract ferrous material, and their attraction is permanent. It's honestly remarkable, but is there an equivalent for static electricity? You know, an object with a permanent static charge? Instead of attracting only ferrous materials, an object which can attract everything else. After spending the past month digging into studies, poring over manufacturing techniques, and formulating my own recipes, there is such a thing. Let's get right to it. There are so many hidden gems of high voltage physics I've had my eyes open to in recent years. Things from levitation, ionic thrust, nebulography, nuclear fusion, to name a few. But electrets, they're in a class all of their own. Electrets are materials which can retain a semi-permanent electric charge, much like how magnets hold a magnetic field. Whereas a magnet has a north and south pole, these have a negative and positive side, meaning they produce permanent static electric fields. And we're all familiar with what a static electric field feels like. Electrets are really cool and have commercial uses I'll talk about later, but when it comes to the larger sizes, well, those are all experimental and you can't really buy them. And I wanted to make a big one. I got to work researching how exactly they're made, and fundamentally, it's pretty easy. An insulating material is melted, then placed between two electrodes charged to several thousand volts DC. Power is applied the entire time it cools and hardens, leading to a reorganization of charges within the material. That reorganizing comes in a few forms, the most common being molecules lined up in chains of positive to negative, leading to an overall mass of charged material with a positive and negative plate. That's very similar to how magnetizing an object works. As for what insulating material to use, it didn't take long to find the original recipe. Electrets were first made in the 1800s, and Oliver Heaviside originally coined the term electret, but it wasn't until Motojiro Asano, a Japanese physicist, came up with the first repeatable formulation for electrets in 1925, using carnauba wax, rosin, and beeswax. Those materials are easily available today, and I've got the high voltage, so how hard could it be? After a quick search, I found all the materials at local craft stores, and considering they'd be melted, they'd need an appropriate mold. A cylinder shape seemed easiest, and it was a quick print with my Prusa. Once printed, I covered the top and bottom of the assembly with aluminum foil tape, effectively creating two plates to be electrified. For high voltage, I employed the custom flyback from my last video, which at full power produces upwards of 65 kilovolts. I dialed it back a bit and connected it to a voltage multiplier. This setup provided a clean 40,000 volts DC at low current, perfect for forming a large electret. Sick! I should have everything I need to make an electret. I've got the materials, the mold, and the super high voltage power source. This should be pretty straightforward, so I'm just going to get straight to melting the materials.
you know it, it's time for a montage.
It's pretty wild.
Yeah, he needs help with his 3D design skills, but the rest of it's pretty fun.
So you can hear the really strong static hiss. That indicates a really strong static electric field. Just barely too strong for the setup. But that's really good. It means this electret's probably going to turn out well. This corona is really beautiful, but it indicates the mold really couldn't handle the voltages applied. While the wax was cooling under the influence of high voltage, I went on to tackle the next obstacle, which was how am I going to test if the wax has become an electret? And if so, how strong is the electric field? Well, I would need a static field detector, which those only take a couple of minutes to build. Quick and dirty, here's the static detector I'll be using for all my tests. You can see the LED on top is unlit. It only lights up in proximity to a positive static electric field. This is super sensitive, like it's annoyingly sensitive. So let's see what it can do. This is what I mean by sensitive. Here I pulled out my Van de Graaff and placed it over 2 meters away. So the generator is running and I'm gonna take my finger off so it builds up a charge. Boom, it took 1 second. Ooh, okay, oh look at that. So as I point my finger at the generator, it loses charge.
It's so cool.
Whoop. And the detector indicates
He's grounding the field
how
locally.
far out the static field is going. That's so crazy. Now, why would pointing at the Van de Graaff turn off the detector? The answer is as beautiful as it is simple. If you think you know, leave your answer in the comments down below. So after an hour or so, the wax had cooled and I was thrilled to test out my new static object. Okay, so here's the electret. If I made this correctly, there should be a permanent static field. Let's see what it does. Nothing yet. Nothing? Nothing? What? It was at this moment that I realized that this would be a journey. So a bit of reading later, and I was encouraged to try again, but this time with the conductive plates facing inward in contact with the molten wax. A quick redesign and print, and I felt really confident that this would do the trick. Whereas the last ones had foil on the outside, these have foil on the inside. Another dose of measuring, melting, stirring, and pouring, and it was time for round 2. Quick note, don't bend down and stare into a wax mold. I legit splashed wax on my face doing this. Round 2. Oh, hello there. Okay, so we've got like a very, very weak static electric field. Oh God, it's so weak. So plates in contact with the molten material helped, and technically, I created an electret. Granted, the weakest electret in the Milky Way, but I think I know why that is. Just like the first mold, the second had issues with arcing and coronal discharge, meaning a strong electric field was never really able to build up on the top and bottom. Meaning the molten wax didn't experience a strong enough electric field while cooling. So back to the drawing board and another redesign. This mold employed foil edges tapering outward and greater spacing between plates. It also would be closed the entire time and wax poured in the top to ensure both plates are in full contact with the wax. So I've given it about an hour and the wax has completely cooled and hardened in the presence of a static electric field, a really strong one. I've had about 10 kilovolts applied the entire time. So the next step is I remove the power and instantly short out both sides of the electret. I then wrapped it up in aluminum foil to preserve all charges and let it sit for a day because I was hungry and I heard a knock at the door. So I'm a really active person. I run in the mornings, I lift weights at night, sponsor calorie smart, keto, protein, on the paired, and it can be fitness and flavor, which is why I've always loved 50% of the process of cleaning this off. We're a bit different this time. So I'm in the process of cleaning this off and I've noticed that as I try to pick off the wax, it's actually kind of sticking to the form, like statically sticking. So that makes me really excited. Demolding it took a bit of work, but this was a good sign. It indicated the wax made full contact with the plates during cooling. All right, there's one side of it. Attempt number 3. Ooh, you see that? That's like 9-10 inches away. Oh my God. Oh, that's cool. Look at that. Okay, so as I rotate the positive pole, brighter, brighter, brighter. Oh, this is so much more potent than the second version. I mean, second version was a 1/4 inch, and I mean, this is like 9 to 10 inches away. Definitely a step in the right direction. Preventing energy loss between the plates, sparking, coronal discharge, made a massive difference, and that makes perfect sense. Literally 3rd time's the charm. This is an actual electret material, and I didn't even use the best materials. I just used the traditional method. Better materials. There's 2 main variables which influence strength of an electret: strength of electric field during cooling and material choice. The more electrically resistive a material is and prone to polarization during molten state, the better that material is for electrets. Here's our wax mixture, and here's polyethylene, which I happen to have in stock. This meant round 4 and a freshly printed mold, this time with an upgrade. One final
Yeah, let me
try,
just
and I'm
grab
feeling
my
great about this
$80
design.
block
You'll notice
off
the
the
orange
shelf.
ring, that is a thick insulator between the top and bottom plates. That
Dude,
helps
this is
prevent
getting
sparking between the
crazy.
plates and also coronal discharge from
Yeah, I
forming,
really like
which
it.
leaks energy out of the system and reduces the final strength of the electret. So let's give it a try. And this time I'm trying some polyethylene.
What? He just cut off about $20.
Yeah.
This was pretty interesting. When molten, the
Look at
polyethylene
that.
turned crystal clear and had the consistency of cold honey. Not quite pourable, but liquid enough. It's holding up okay, but the separator, the insulator, melted off. So it's about to melt into a puddle. A few hours later, I was greeted with a
Super
really beautiful
Corona
sight.
dope.
A perfect little hockey puck of electrical doom. It formed perfectly, and I could feel the hair on the back of my hand standing up as I held it. Got a tiny piece of foil stuck in the bottom, which I'd need to dig out, but otherwise perfect. Feeling good about this. Woo! That's a foot and a half. So this is pushing about 2 feet away. That's so interesting. Yeah, I'm pretty happy with these results. I'm gonna wager this is strong enough to pick something up. Oh yeah. There we go, that's a permanent static charge. Massive success. I mean, let's review all the attempts. In terms of detector light up distance, first iteration, no effect. Second, 1/4 inch. Third, 9 to 10 inches. And the fourth and final version, upwards of 2 feet. If that's not proof that you should never give up, I don't know what is. Clearly, polyethylene plastic is superior for electret use and holding a strong static electric field. But what does that electric field look like? I'm gonna need more than one detector. My
This
plan was
isn't
to do a
necessarily
5x5 array
anything
of
we need to
identical
watch.
static
This is his
sensors.
detector that doesn't really pertain to the science.
Well, that was still
Awesome.
cool.
It's a good place to cut it off. Yeah, that was awesome, dude. So
Yeah,
he basically
that's a good
made a little static electric magnet, essentially, right? Or like a permanent one.
Yeah,
rather.
permanently
That's
static
insane.
charge. Yeah, for
Is
sure.
he the first person to do that, or is this like a known thing? And he just kind of made like a
No,
good
no,
one?
that was what's his name long ago who did
Heavy
it.
side.
Ollie did it. Heavyside. He did it a long time ago.
Oh wow.
I remember when I
Oh.
first read the term electret, like 20 years ago when I was reading about electrostatics and stuff, and I'm like, what the hell is an electret? It took me years to figure out even what the hell they were talking about. Because everybody writing the journal and reading the journal, like, whatever, back then, I guess they all just, oh yeah, electret, no. But like, no, I had no idea what they're talking about for the longest time.
Crazy.
We're gonna run it
Am I
out.
the only one that?
Oh, sorry. Go ahead.
Am I no? Yeah, I just saw the picture of Oliver Heavyside. It's like, am I the only one that was wishing he was like a little bit heavier than that, a little fatter maybe?
It was
Then he
more
could do the Wolverine
Oliver
thing.
Whiteside.
Yeah.
Nice. All right. No, we can the ItsBS video is like 20 minutes. He has a truncated one on Twitter that's like 6 minutes, but I can't find it. But I linked it in the chat, so it should be good. People could watch that on their own. But he does a really good steelman at the beginning of the issue put forward by the modern interpretation, where the charge is stored on the plates by little tiny ballistic balls that are just hanging out as a surplus of charge. But so definitely check that out. But all right, well, thanks for everyone who showed up. Thanks for everyone who helped support the merch store. Much appreciated. And stay tuned for some more celestial theodolite measurements. Now we're going to add to the database there. And let's see what we got coming up for the rest of this week. I don't think we have anything coming up until next Tuesday, where Shane will be doing a presentation on something. What's up?
Thursday night in the club, right?
Oh, that's right. Thank you, sir. We are doing Thursday night Clubhouse, 8 p.m. Eastern time. Check that out. We're going to go over there, talk a little celestial theody, answer some questions, and hang out with the lads and ladettes over there. Thank you, Stone, for reminding me of that.
Yeah, the newly built clubhouse. Can't forget that.
All
Cool picture.
right, guys. See you